Hello dear students, my name is Rahul Chuk and I welcome you all to my YouTube channel Farmers. Today we will going to see some important objective questions from the topic suspensions biphasic dosage forms. So let's get started. So moving on a very first question of our today's session, and that is, in a suspension the particle sizes, we have to identify the particle size or the given four options in a suspension, and the options are 5 to 10 micron, 10 to 15 micron, 0.5 to 5 micron या 8 to 12 micron. So जो suspensions होते हैं, they are the coarse dispersion where the solid particles are dispersed in liquid. So we can say these particles generally have a size range in between 0.5 to 5 microns that allows them to remain suspended but eventually settles. So we can say option C, that is 0.5 to 5 microns are the particle size in a suspension. Moving on to the next question, we have an example of a flocculating agent that is used in suspension. Now we have to identify example of flocculating agent out of the given four options that is used in suspension. So the options are sodium carboxymethyl cellulose, sodium alginate, sodium lauryl sulfate या bentonite. So जो sodium alginate होता है, that basically act as a flocculating agent by forming a gel-like network that promotes loose aggregation, that is flocks of particles. In contrary, जो सोडियम कार्बोक्सी मिथाइल सेल्यूलोज होता है, दैट विल गोइंग टू एक्ट एज अ सस्पेंडिंग एजेंट. जो हमारा सोडियम लोराइल सल्फेट होता है, दैट विल गोइंग टू एक्ट एज अ सर्फेक्टेंट. एंड जो हमारा बेंटोनेट होगा, दैट विल गोइंग टू एक्ट एज अ सस्पेंडिंग एजेंट. सो वी कैन से ऑप्शन बी, दैट इज सोडियम एल्जिनेट, will going to act as a flocculating agent used in suspension. Moving on to the next question, which is the incorrect statement of the flocculated suspension? We have to identify an incorrect statement for flocculated suspension out of these given four options. And the options are: particle forms a loose aggregate structure, sediment is formed slowly, sediment is loosely packed, and sediment is easy to redisperse. So, in a flocculated suspension, जो sedimentation होती है, that occurs more rapidly because of the flocks are larger and settles quickly. So, however, they will going to form a loose sediment and that is easy to redisperse while shaking. Hence, statement B that says sediment is formed slowly is the incorrect one, as the sediment is formed rapidly in case for flocculated suspension. So we can say option B is the correct answer of this question. So moving on to the next question. A quaternary ammonium compound that can be used as an antimicrobial in suspension. हमें एक क्वाटनरी अमोनियम कंपाउंड फाइंड आउट करना है जो कि एंटीमाइक्रोबियल के तौर पे यूज किया जा सकता है इन सस्पेंशन में. ऑप्शन दिए गए हैं प्रोपाइल पैराबेन, फिनॉक्सीथनॉल, क्लोरोक्रेसॉल और सेट्रीमाइड. सो इन चारों ऑप्शंस में जो सेट्रीमाइड है, दैट इज अ क्वाटनरी अमोनियम कंपाउंड with an antimicrobial activity that oftenly used in pharmaceutical suspension to prevent microbial contamination. So we can say option D, that is cetrimide, is used as an antimicrobial in suspension and it is a quaternary ammonium compound. Moving on to the next question. Incremental particle size measurement is done by the diameter. We have to find out the diameter, which diameter, which is measured by using the Anderson pipette method of sedimentation. Options are surface number diameter, Stokes diameter, length number diameter, volume number diameter. So जो Anderson pipette होता है, that basically used to measure the particle settling rates, and from this data the Stokes diameter that based on the sedimentation velocity is calculated by using the Stokes law. So we can say option B, that is Stokes diameter, is the correct answer of this question. Moving on to the next question. In coarse dispersion, the condition when no clear supernatant is shown on standing is known as. Options are ionic equilibrium, Donan membrane equilibrium, flocculation equilibrium, phase equilibrium. So, in a flocculated system, the particles are suspended as loose aggregates, creating a uniform cloudiness without a clear supernatant, indicating a flocculation equilibrium. So, we can say option C, that is flocculation equilibrium, is the correct answer of this question. Moving on to the next question. A suspensoid in suspension formulation is. Options दिए गए हैं: an active drug, a solubilizing vehicle, a wetting agent, a preservative. So, a suspensoid refers to the finely divided, insoluble active pharmaceutical ingredient dispersed in suspension medium. So, we can say option A, that is active drug, is considered to be a suspensoid in suspension formulation. So moving on to the next question. The factors affecting the rate of settling particles of suspension are based on ऑप्शन दिए गए हैं राउल्ट्स लॉ, स्टोक्स लॉ, हेनरी लॉ, गे-लिवसेक लॉ. So जो हमारा स्टोक्स लॉ होता है that basically used to govern the sedimentation of spherical particles under the gravity, and it is a key in predicting the settling of the suspension. So we can say option B, that is Stokes law, is the correct answer of this question. Moving on to the next question. Which of the following statements is true for flocculated suspension? नीचे दिए गए चार स्टेटमेंट में से फ्लोक्युलेटेड सस्पेंशन के तौर पे कौन सी स्टेटमेंट सही है? A hard cake is formed, the rate of sedimentation is high, they are difficult to redisperse, suspension is pleasing in appearance. So जो flocculated system हमारा होता है, they are basically settles quickly due to flock formation, but it will going to form a loose sediment that is easy to redisperse. So we can say option B, that is the rate of sedimentation is high, is a correct option, while option A and C that says a hard cake is formed and they are difficult to redisperse are considered to be false, and they are basically related to deflocculated suspensions. So we can say option B is the correct answer to this question. Moving on to the next question. Which among the following is a thickening agent for a suspension except नीचे दिए गए और चारों ऑप्शंस में से we all have four thickening agents. We have to find that out of these four, one is not a thickening agent. So we have to find that one. Options are acacia, tragacanth, starch, lactose. So acacia, tragacanth and starch are natural thickening agent, while lactose is an inert filler that is not used in thickening of suspension. So we can say option D, that is lactose, is the correct answer of this question. Moving on to the next question. The shake well before use label must be put on the one of the following. नीचे दिए गए चार ऑप्शंस में से शेक वेल बिफोर यूज का लेबल किस पे लगा होना जरूरी है? ऑप्शंस दिए गए हैं ऑप्थेल्मिक जेल्स, ऑक्यूसर्ट्स, ऑप्थेल्मिक सस्पेंशन, ऑप्थेल्मिक सॉल्यूशन. सो जो सस्पेंशंस होते हैं they tend to settle over time and hence they need shaking to redistribute the drug uniformly before use. So we can say the suspension, ophthalmic suspension, option C, is the correct answer of this question. So moving on to the next question. A thick, viscous formulation consisting of aqueous suspension of insoluble inorganic drugs is, options are lotion, paste, elixir, magma. So the magma refers to a thick aqueous suspension like milk of magnesia that contains fine insoluble inorganic particles. So we can say option D, that is magma, is a thick viscous formulation consisting of aqueous suspension of insoluble inorganic drugs. Moving on to the next question. The particles that are loosely bonded, settle rapidly, and are easily redispersible are known as coagules, defloccules, floccules, sediments. So जो floccules होते हैं that they are loose, fluffy aggregates that settles quickly and can be easily redispersible or resuspended by shaking. So we can say option C, that is floccule, is the correct answer of this question. Moving on to the next question. Which is not correct for deflocculated suspension? Out of the given four options, we have to find the incorrect statement for deflocculated suspension. So options are the chances of cake formation are more, the particles settle fast, particles represent a separate unit, sediment is difficult to redisperse. So in deflocculated system, individual particles settle slowly and compact tightly over time, leading to a hard cake formation. So option B, that states particles settle fast, is the incorrect one, as in deflocculated suspension the particles settles slow, not fast. Moving on to the next question. Example for semi-synthetic thickening agent in suspensions is, options दिए गए हैं polysorbate, tragacanth, carboxylase, microcrystalline cellulose. So the microcrystalline cellulose is a semi-synthetic thickener that is used to stabilize the suspension, while tragacanth is a natural one. Carboxylases are the polymers like PEG. PEG stands for polyethylene glycol, and the polysorbates act as a surfactants. So we can say option D, that is microcrystalline cellulose, is an example of a semi-synthetic thickening agent that we used in suspensions. Moving on to the next question. The sediment consists of loosely packed particles possessing a scarf-folding-like structure is seen in options दिए गए हैं flocculated suspension, Newtonian suspension, non-flocculated suspension, or all of these. So only flocculated suspension show a scaffold-like loosely packed sediment that is easy to redisperse. So we can say option A, that is flocculated suspension, is the correct answer of this question. Moving on to the next question. The stability of suspension can be evaluated by options are sedimentation volume, degree of flocculation, and redispersibility, or all of these. So a suspension stability involves multiple factors जैसे कि particle settle rate that tells you about sedimentation, how they cluster, that is flocculation, and whether they can be resuspended or redispersed on shaking, that is redispersibility. So we can say option D, that is all of these, is the correct option for this question. That is sedimentation volume, degree of flocculation, and redispersibility all can be used to determine or evaluate the stability of suspensions. Moving on to the next question. Polymorphism is important in the formulation of options are solutions, ointments, capsules, suspensions. So, in suspension, the physical form, that is polymorph of a drug, can significantly affect its solubility, dissolution rate, and stability. So we can say option D, that is suspension, is the correct answer of this question. So moving on to the next question. Degree of flocculation of a suspension is expressed as डिग्री ऑफ फ्लॉकुलेशन ऑफ सस्पेंशन को किस तरीके से एक्सप्रेस किया जाता है. ऑप्शन दिए गए हैं रेशियो ऑफ वॉल्यूम ऑफ फ्लॉकुलेटेड सेडिमेंट टू टोटल वॉल्यूम ऑफ सस्पेंशन, रेशियो ऑफ टोटल वॉल्यूम ऑफ सस्पेंशन टू वॉल्यूम ऑफ फ्लॉकुलेटेड सेडिमेंट, रेशियो ऑफ सेडिमेंटेशन वॉल्यूम ऑफ फ्लॉकुलेटेड सस्पेंशन टू द सेडिमेंटेशन वॉल्यूम ऑफ द सस्पेंशन व्हेन डीफ्लॉकुलेटेड, या सेडिमेंट वॉल्यूम ऑफ फ्लॉकुलेटेड सस्पेंशन. सो जो डिग्री ऑफ फ्लॉकुलेशन होती है that used to compare the sediment volume in flocculated and deflocculated state to assess the stability. So we can say option C, that states ratio of the sedimentation volume of the flocculated suspension to the sedimentation volume of the suspension when deflocculated can be represent or express the degree of flocculation of a suspension. Moving on to the next question. Hickson and Crowell cube root law is related to options are microemulsification, drug dissolution, stability of API against hydrolytic degradation, या sedimentation in liquids containing more than 10% of suspended particles. So this law, that is Hickson and Crowell's cube root law, relates to the cube root of the particle size to the dissolution rate that helps in studying how drugs dissolve over time. So we can say option B, that is drug dissolution, is related to Hickson and Crowell's cube root law. Moving on to the next question, which is known as milk of magnesia. नीचे दिए गए ऑप्शंस में से मिल्क ऑफ मैग्नीशिया किसे कहा जाता है. ऑप्शंस दिए गए हैं सस्पेंशन ऑफ मैग्नीशियम हाइड्रोक्साइड, सस्पेंशन ऑफ मैग्नीशियम ऑक्साइड, सस्पेंशन ऑफ मैग्नीशियम कार्बोनेट, suspension of milk and magnesium oxide. So milk of magnesia is a suspension of magnesium hydroxide that can be used as an antacid or as a laxative. So we can say option A, that is suspension of magnesium hydroxide, is also known as milk of magnesia. Moving on to the next question. Which of the following is an example of external preparation of suspension containing indiffusible solids? नीचे दिए गए में से इन नीचे दिए गए चार ऑप्शंस में से कौन एग्जाम्पल है ऑफ एक्सटर्नल प्रिपरेशन ऑफ सस्पेंशन जो कंटेन करता है इंडिफ्यूजिबल सॉलिड्स को. सो ऑप्शंस आर सल्फाडिमिडीन, हाइड्रोकॉर्टिसोन, फिनोबार्बिटॉन या एस्पिरिन. सो जो हाइड्रोकॉर्टिसोन होता है दैट इज ऑफनली यूज्ड इन टॉपिकल सस्पेंशन वेयर सॉलिड्स आर नॉट रेडिली डिस्पर्स्ड और दे आर इनडिफ्यूजिबल सॉलिड्स के फॉर्म में वो प्रेजेंट होते हैं. सो वी कैन से option B, that is hydrocortisone, is an example of external preparation of suspension containing indiffusible solids. So moving on to the next question. In the extemporaneous preparation of suspension, the levitation is used to. extemporaneous preparation of suspension के दौरान levitation का यूज किस लिए किया जाता है. ऑप्शंस दिए गए हैं reduce viscosity, reduce zeta potential, reduce particle size या all of these. So we can say जो लेविगेशन है that involves the grinding of powder with a small amount of liquid that helps to reduce the particle size and ensure the smooth dispersion. So we can say uh, in extemporaneous preparation of suspension, levitation is used to reduce the particle size. So option C is the correct answer of this question. Moving on to the next question. Which of the following is related to a suspension? नीचे दिए गए में से सस्पेंशन से कौन रिलेटेड है? ऑप्शंस दिए गए हैं स्टोक्स लॉ, ब्राउनियन मूवमेंट, जीटा पोटेंशियल या ऑल ऑफ दीज. सो ऑल दीज फैक्टर्स इम्पैक्ट सस्पेंशन बिहेवियर, जैसे कि जो स्टोक्स लॉ है दैट गवर्न्स द सेटलिंग रेट या सेडिमेंटेशन. ब्राउनियन मूवमेंट इज रिस्पॉन्सिबल फॉर पार्टिकल मोशन, while the zeta potential acts or play role in particle charge. So we can say option D, that is all of these like Stokes law, Brownian movement and zeta potential, all of them are linked or related to suspensions. Moving on to the next question. Higher zeta potential gives deflocculated type suspension and results in options are sedimentation, transparent form, cake form, brittle form. So higher the zeta potential keeps the particle apart, causing the tight packing and hard cake formation over time. So we can say option C, that is cake formation, is the correct answer of this question. Means higher the zeta potential gives deflocculate type suspension and it's going to result in a cake formation. Moving on to the next question. Which of the following which is used as a natural thickening agent in suspension? अगर हमने देखा हो, हमने पहले पढ़ा था विच द फॉलोइंग एक्ट एज अ सेमी सिंथेटिक टाइप ऑफ थिकनिंग एजेंट इन सस्पेंशन. उसका आंसर था माइक्रोक्रिस्टलाइन सेल्यूलोज. यहाँ पे पूछा गया है विच ऑफ द फॉलोइंग इज यूज्ड एज अ नेचुरल थिकनिंग एजेंट इन सस्पेंशन. सो ट्रैगाकैंथ इज अ प्लांट based derived gum used to increase the viscosity and to suspend the particles naturally. So we can say option B, that is tragacanth is a natural thickening agent in suspensions, while microcrystalline cellulose is a semi-synthetic thickening agent that we use in suspensions. Moving on to the next question. The concentration of sodium carboxymethyl cellulose for injectable suspension is, so sodium carboxymethyl cellulose की concentration we have to find out for injectable suspensions में. Options दिए गए हैं up to 5%, up to 0.5%, up to 2%, up to 1%. So जो injectable suspensions होते हैं they required low viscosity for syringeability. So sodium carboxymethyl cellulose, sodium CMC, is typically used as equal to or less than 0.5% to avoid clogging of needles. So we can say option B, that is up to 0.5% is the concentration of sodium carboxymethyl cellulose for injectable suspension. So moving on to the next question. Maximum sedimentation volume will be obtained when the zeta potential is, zeta potential कितना होना चाहिए जब हमें maximum sedimentation volume मिले. ऑप्शन दिए गए हैं नेगेटिव, न्यूट्रल, पॉजिटिव, जीरो. सो zero zeta potential minimizes the repulsion between the particles, which allows them to form loosely packed flocks and maximize the sediment volume. So we can say option D, that is 0, is the right answer of this question. And when the zeta potential becomes 0, we will going to obtain our maximum sedimentation volume. Moving on to the next question. The term used to determine the protective power of lyophilic colloid is, options are oxidation number, coagulation value, gold number, critical micelles concentration. So जो the gold number होता है that quantifies how much lyophilic colloid is required to prevent the coagulation of gold sol. The lower the number, the higher the protective power of lyophilic colloid. So we can say option C, gold number, is the term that is used to determine the protective power of lyophilic colloid. Moving on to the last and the final question of our session. The principal limiting factor in the rate of absorption from suspension is, options are suspending agent, viscosity, dissolution rate, या physical stability. So the dissolution of a solid drug particles into the surrounding fluid is the essential step that governs how the fast a drug that can be absorbed. So we can say option C, dissolution rate is the principal limiting factor in the rate of absorption from the suspension. So that's it from the today's session from the topic suspension biphasic dosage form. I hope that these MCQs will going to help you to sharpen your preparation. If you like the video, then don't forget to like, subscribe, and hit the bell icon for more pharmacy insights. Thank you.